Generally speaking, it is possible to directly find the inverse function and then find the derivative to compute the slope of tangent line. But it can be especially difficult to find the inverse function for complex equations or functions, where it is challenging to obtain the inverse function directly. In such cases, using the derivative of the original function to calculate the derivative of the inverse function can be a simpler approach. To find the derivative of the inverse function, you can use the inverse function theorem. Let's say you have a function f and its inverse function is denoted as g. If f and g are both differentiable on an interval, then the derivative of inverse function is reciprocal of f prime of g of x. Of course, the denominator cannot be 0. This result follows from the relationship between the slopes of the tangent lines of the original function and its inverse at corresponding points. Let's consider an example to demonstrate how to find the derivative of an inverse function. Let's start with the function f of x equals x squared. We want to find the slope of the tangent line to the inverse function at 4, 2. Step 1. Find the derivative of the original function, f prime of x equals 2x. Step 2. Evaluate the derivative of the original function at x equals 2. F prime of 2 is 4. This means the slope of tangent line at x equals 2 is 4. Step 3. The derivative of the inverse function at the point, 4, 2, is the reciprocal of f prime of 2. Therefore, the slope of the tangent line to the inverse function at x equals 4 is 1/4. When you plot the graphs together on the same coordinate plane, you can clearly observe their relationship. See you next time!